Alright, so today we're on day 2 of writing polynomial functions given the zeros. So as you can see, I'm going to be doing 5 of the 20 problems, and then the remaining 15 will be for you to do for homework. It shouldn't be that long of an assignment because, again, I'm only asking, it says least degree, and we're going to write it in factored form. So we'll go ahead and jump right into it. On number 1, we have 2/5, 2, and 1/5 as our zeros. So remember that that means x equals 2/5. So we want x equals, well, x plus or minus something equals 0. So I'm going to multiply by 5 on both sides. That gives me 5x is equal to 2. Then I still want that equals 0, so I'm going to subtract 2 from both sides. And I get 5x minus 2 is equal to 0. And so that means my factor that belongs there is 5x minus 2. Then for the 2, we know our factors take the opposite sign, so we would have x minus 2. Let me write this as a factor. And then for the last one, we have a fraction again. So whenever we have a fraction, I like to write it as x equals that number, and then we want it to be x plus or minus something equals 0. So we're going to multiply by 5 on both sides. 5x is equal to 1, but I still need equal to 0, so I'm going to move that 1 over. And I get 5x minus 1 is equal to 0. So then my factor there is 5x minus 1. So when I'm writing the function, f of x would equal 5x minus 1 times x minus 2 times 5x minus 1. Then on number 3, it says 1 with a multiplicity of 2 and negative 3. So if I need 1, I have a factor that would look like this. If I need negative 3, I have a factor that looks like this. So we take their opposite sign to make their factors, and then the only thing that I have left is the multiplicity of 2, which means that linear factor would appear twice. And I can write that as my function equals x minus 1 multiplied by itself, which is the same thing as squaring it, times x plus 3. And on number 9, we have all fractions. So we're going to say x equals 1/5. And we're going to solve that to make it x plus or minus something is equal to 0. So we got 5x equals 1, subtract the 1, and 5x minus 1 is equal to 0. So that's one of my factors. And for 3/4, we'll do the same thing. X equals 3/4 multiplied by the denominator. 4x is equal to 3, and subtract 3. And 4x minus 3 is equal to 0. So 4x minus 3 is the corresponding factor. And then x equals 1/4 multiplied by 4. 4x equals 1, subtract 1, and 4x equals 0. Sorry, 4x minus 1 equals 0. Which means my factor is 4x minus 1. So when I'm writing my function, you get 5x minus 1 times 4x minus 3 times 4x minus 3. So if you see that when we multiply these back out to get our standard form, we would have a 5x times an x times a 5x at some point. And 5x times 5x is not going to give me a lead coefficient of 1. So we're going to ignore that part on our instructions for the first page. Now on the second page, it doesn't have that part of the instructions. So we are just writing the polynomial function of least degree, and we're given the zeros. On number 11, we have 0 with a multiplicity of 3, and then a 0 of negative 1. So when we have 0, we know that's just x. When we have negative 1, comes from the opposite of x plus 1. The multiplicity of 3 is the power on it. So I have x cubed times x plus 1 as my function. Now on the second page, whenever you have something easy, let's go ahead and put it in standard form. So since I have x cubed times x plus 1, to make that standard form, I'm going to distribute that x cubed. And I get x to the power of 4 plus x cubed. And that is my function. Now on number 13, we're given some weird looking zeros, right? So we've got radicals in there, and they're not just fractions like we're used to seeing as our weird zeros, but we will do them the same way. So x is equal to square root of 2. I want something x plus or minus something equals 0. So a number times x plus or minus a number equals 0. So how do I get rid of a square root? Well, first I'm going to square both sides. I get x squared equals 2. Now what I still need to do is get this to equal 0, so I'll subtract the 2. And I get x squared minus 2 is equal to 0, so my factor is x squared minus 2. Now in the second one, we have negative 1 plus the square root of 2. I'm going to write x equals, And what I want is for that to say x plus or minus something is equal to 0. So what I'm going to do first is get rid of this 1. I get x plus 1 is equal to plus or minus the square root of 2. I'm sorry, why am I writing plus or minus? That just says plus. So equals positive square root of 2. And we'll square both sides. So So the left side is going to be x squared plus 2x plus 1 is equal to, and then 2. And I still need it to say equals 0, so I'll subtract 2 from both sides. And x squared plus 2x minus 1 equals 0. So we're looking at x squared plus 2x minus 1. And on the next one, we have the same thing, but with a minus. So x equals negative 1 minus square root of 2. First thing I'm going to do is add 1 to both sides. Get x plus 1. Getting ahead of myself. And that equals negative square root of 2. And then we see that we're left with a negative square root of 2. So whenever we square something that's negative, we're left with something positive, right? So if I take negative 1 and I square it, that's negative 1 times itself, which would be a positive 1, because a negative times a negative is a positive. So we're going to square both sides. And remember, when we square negative square root of 2, we're taking it and multiplying it by itself. Negative times a negative is a positive, so this is really just square root of 2 times square root of 2. Whenever you have a radical multiplied by itself, you just remove the radical symbol, and so this is just 2. So we're left with x squared plus 2x plus 1 is equal to 2. And then we'll subtract 2. And we get x squared plus 2x minus 1 is equal to 0. And we see that that's the exact same as the one from before. Because when you try to solve that, you're going to end up with a plus and a minus, and that's where we get the same thing twice with 2 different space. But when we're writing our function, since this is a long one, we're not going to write it in standard form. We get x squared minus 2, and then x squared plus 2x minus 1. Now, do we need to write that twice? Let's think about it. If I was solving x squared plus 2x minus 1 equal to 0, at some point, I'm going to end up with plus or minus the square root of 2, right? That gives me both of these factors. So it is not a multiplicity thing. It is that when we solve, we end up with 2 separate parts. So that is a little complicated there. That is our answer to number 13. So I want you to try your best on the ones with radicals on them, which are the remaining ones on the page. The ones that are more complicated, that it's not a multiplicity issue, but it is an issue of something that would give you 2 separate parts, like x squared plus 2x minus 1, are the ones that are exactly the same with the different signs. So like on number 16, it's going to be something like number 13. Now I do want to go back and just talk a little bit about on the first page if we did want to make the lead coefficient 1. Now in order to make the lead coefficient 1, we would have to have something multiplying by everything that would get rid of that that lead coefficient in each of the factors. So on this one, let's write in black. On this one, if I wanted to get rid of a lead coefficient of 5, what would I multiply this whole thing by? Well, I can divide everything by 5, which is the same thing as multiplying by 1/5. with x minus 2, I already have a lead coefficient of 1, so I don't need to change that one. And then 5x minus 1 needs something in the front. It's going to be the same as the other one. It's 1/5. So we're taking each of these and multiplying, which we don't need to be in a specific order when we're multiplying. So we could take those numbers in the front and take them out. I'm sorry, that should say 2. Why didn't anyone correct me? Okay, and then x minus 2, 5x minus 1. And what is 1/5 times 1/5? Well, it's 1/25. So in order to make this have a lead coefficient of 1, we would have to multiply this entire thing by 1/25. So this is just a little extra bit, and I do encourage you to try it on some of them, see what you would have to do to make your lead coefficient 1, but I won't be checking for that on the homework assignment. I will just be checking that you have your factored form. So like on number 9, let's look at that one really quickly. If I wanted to make this lead coefficient 1, I need to get rid of that 5. I need to get rid of that 4. I rewrote the same thing again that I did on the first one. And I need to get rid of that 4. So I need to multiply this first one by 1/5, this one by 1/4, and this one by 1/4. So taking all of those fractions, I have 1/5 times 1/4 times 1/4 times each of the factors. And so we have 1/5 times 1/4 times 1/4, which is 5 times 4 times 4, which is 20 times 4, which is 80. So we've got 1/80. Oops, messy looking. That we would need to multiply this entire thing by in order to get a lead coefficient of 1. So the answer that I would want to see on your paper is this one over here. But if you want to play around with it and see what would I need to multiply this entire thing by to get a lead coefficient of 1, then you can do that. I do encourage you to do that. And then on the second page, don't worry about that at all. We're still writing in the polynomial function in factored form for the messy ones. But if you can, like on number 11, go ahead and write it in standard form. Make sure you turn this in on Canvas, and then I will see you guys tomorrow.